Hello friends, this video on periodic classification of elements part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1. Let's study the history of periodic table, how this periodic table came. The first thing happened is 1979. That time there were 33 elements. I think I have discussed the history of elements, the metals and non-metals, how it came, right? So by 1789 there were only 33 chemical elements, only 33, right? So that time this guy Lavoisier, what he did was he published a list of these 33 elements and he grouped them into gases, metals, non-metals and earth. These were the classification at that time, right? So these 33 elements he grouped because the list increase is easy to group and then find, right? So he grouped these 33 chemical elements into these groups, and that was the first effort to group these elements. They were elements, but nobody bothered to group those. This is the first effort by Lavoisier to group these elements. And then this guy came, Debonnier. So this guy Debonnier, what he did was he grouped the elements into triads based on their chemical property. We'll discuss more in detail about these. And then he observed that the atomic mass or the middle one is equal to the mean of the first and last, right? So we'll explain more on these, but he tried to group these elements based on the atomic weight. So this was the first grouping happened in 1789 based on the whether it's metal, non-metal or earth. These guys did the grouping based on the atomic weight. So this is the first time somebody tried to group based on atomic weight, where atomic weight was used. And let me tell you one thing, this atomic weight, how it came was, you remember the history 1804. Yeah, 1804. Because till 1789 there was the concept of atomic weight was not there. Okay, the concept of atomic weight came in 1804. How? This guy Dalton, you must have heard about this guy, right? John Dalton. He gave this atomic theory that the atom, I mean everything is made of a particle called atom, which is unbreakable. That time he told, and then the law of conservation of mass applies in this case also. And then with that, what happens is all these chemists, they did a lot of reactions, chemical reactions, right? For example, hydrogen reacts with water to give H2O, and they made a balanced reaction. And from that, they found that some gram of this guy reacted with some gram of this to get this. So with all these reactions, and we call stoichiometry, they found the atomic weight of the elements. For example, hydrogen has some atomic weight, oxygen has some atomic weight. These atomic weights were found based on chemical reaction or stoichiometry. So because this time the electrons was not discovered, right? The atom was not even discovered. Atom was just a hypothetical, you can say hypothetical thing, because these chemists used to believe that there is something called atom, and which is unbreakable, and that will have atomic weight, and this atomic weight was found based on the chemical properties by the reactions, right? So they do different reactions, and based on that they found that, okay, this guy 10 grams of hydrogen reacted with 50 grams of oxygen to form, let's suppose, 60 grams of water. I'm just guessing numbers. So with that, with those values, with a lot of equations, they found the atomic weights of almost all the existing chemical elements. Please note, these were just found by chemical reactions. So at that time, by 1804, and that time I'm talking about that time, atomic number was not even there, right? The only thing that was there was atomic weight for a particular element, and that was decided by stoichiometry, that is by reactions. So with this, but it had a lot of limitations. Then this guy John Newland, he did one great thing, was he again used the atomic mass, because that was the hot topic there in 1800 era, because 1804 is Dalton gave this theory that the atom, I mean anything can neither be created nor can be destroyed, can be just converted, and with that they found the atomic masses of the elements. So he did one thing, he arrange the element just based on the atomic mass, right? So you see that this Debonnier guy, he grouped based on the chemical properties, because this guy also tried to group based on the chemical property, but he also used atomic weight formula. But this guy, he just used atomic weight only, right? He arranged elements just by atomic weight, increasing order of atomic masses, and he found that every 8 element has a property that is equal to the first element. So he started with the first, and that time 56 elements were discovered. If you see 1789 they were 33, and by 1866 they were like 56 elements, right? So he observed that for all these elements, right, so it was following a pattern. So the property of first, and then you go to 8, and then you go to 9. These were matching, right? First and 9th were matching. So I will explain more on this, but just to understand that this guy did a great thing, and he just used only atomic mass, and he just arranged those elements in the order of increasing atomic mass, and he found that every 8 element repeat the property. So that means he found that there was a periodicity in the property of the elements. But it has a lot of loopholes, and it could not accommodate new elements that were found. So this guy, Mendeleev, he did a great job. Actually, I believe that this periodic table is mainly by Mendeleev. So if you see, I feel that 90% of the contribution is by Mendeleev only for the periodic table. What he did was, he arranged based on their fundamental property. There is atomic mass and chemical property. So at that time there were 63 elements. So what he did was, he reacted those elements with oxygen and hydrogen. Some elements with oxygen and hydrogen, because at that time these equations were pretty much known. And then their reaction property he found, and then with that he arranged them in the particular order, and that's almost equal to our new periodic table. But that time he used atomic mass, because obviously that time atomic number was not even known, right? So that guy used this periodic table, and it was a big hit. It was pretty good success, but it had few limitations, very few limitations, and those limitations were covered when this guy Moseley showed that atomic number is a better way to, or better element for creating a periodic table. And please note that this atomic number concept was discovered by this guy only, 1913. If you must have noticed, 1896, this guy Thomson, he found electrons, right? He found electrons, correct? And then since it was found that electrons was neutral charge, so if there are n number of electrons, there has to be n number of a positive charge called protons, right? And with this, this guy Moseley, actually he was not a chemist, he was a physicist, right? So he knew how to find the number of electrons for any element by using the rays emitted by that element, right? So he found a way to find the actually atomic number for any element. So this, by 1896, Thomson told that there is something called this guy electron. And 1890 and 1880 was the era where radioactivity was a hot topic. So you must have seen the Rutherford and Marie Curie, all these people existed at that time, and the radioactivity was a hot topic. And that time this guy was an expert in the radioactivity field, and he was able to find the number of electrons for any given element by observing the pattern of the rays emitted. So we'll not go deep into that. That's, you may study in the higher class in the physics, but just understand that this guy was able to find a new term called atomic number, which is nothing but the number of electrons or protons, right? And then he found that atomic number is a better way to judge or to create a periodic table, right? And with this, the moment he used atomic number, Mendeleev periodic tables anomalies were all gone, and it was a very good periodic table. So we'll learn more in detail about this, but just understand this, how it went. The first effort was by this Lavoisier, 1789. He classified elements into gases, non-gases, and metals, non-metals. Then this guy Debonnier, based on the chemical property, he created tirides, trades actually. Then this guy Newland, he showed that when you arrange the elements in the order of increasing atomic mass, it follows a pattern. So there was a kind of thing that there's a pattern that existed. And with this guy Mendeleev did a good amount of research, and he almost created a periodic table, but that time he was not even aware of atomic number, right? The only thing they could know was the atomic mass, and that from stoichiometry. See, now we have a lot of instruments to actually view the atoms, right? So the physics has helped chemistry to view the atoms, because it has given good instruments to actually visualize the atoms. But at that time, nothing was existing. So the atomic mass was all formed by chemical reactions, and this was the only thing element existed. So this guy created this periodic table based on this, and you see after this, there's a long gap of almost 45 years, right? And then this atomic number came, and this guy found that, dude, if you use atomic number instead of atomic mass, things are fine. And that's what he did, right? And then we got a better periodic table. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.